Good morning, everybody. My name is General Spivacos Jr. and today I will be reporting about the topic identifying parameters, a statistics and probability presentation. Now, as you may wonder, why am I not reporting within class? Well, Sir has assigned us to have a video reporting, so now let's go and move on to the lesson and have fun watching my video. So before we start, I will present to you our objectives, which is free, which is what parameters are, how to identify them, and how they differ from statistics. As you may see, we can objectify them as parameters and statistics as two different things. You might say, oh, what's the difference? Well, I will discuss them as we move on to the topic. So, let us first define the most basic and surface level definition out of them all, which answers the question, what is a parameter? Now from the start, a parameter is a numerical value that describes a population, which means it refers to every member of the group being studied, which refers to everywhere. If you are studying in a school, then it refers to the entire population of the school itself. It represents the true characteristics of that population and does not change unless the population itself changes. Now, a parameter, from the pointers I have given, number 1, it describes an entire population. Number 2, it has a fixed value, but unless the population changes, then that rule does not apply. It is often unknown but assumed to exist, since, for example, within statistics, there is a sample, and now when there is a population, there is a parameter itself. Now, a population and a sample from the parameter has its differences. A population includes all individuals or objects of interest in a study, while a sample is only part of that population. Because studying the entire population is often impractical, or kanang kapoy jud siya, samples are used to make estimates. For example, you have to study 1,000 people of Suarez National High School. Then to provide an accurate estimate, you don't need to survey 1,000 people. You just need to take a sample out of that, a quarter of that, and it would still be the same result because it is an accurate estimation. A population is the 1,000 students in Suarez National High School, and the sample is, let's say, 100 only. That is the population and sample differences. Pretty basic, right? Now that you know it, let's move on to the next slide, which tackles on another part of the population and sample. For simplification, a population is a whole group. A sample is a subset of the population, or another group within a group. And then the parameters describe populations, not samples. Do you know what describes samples? Well, that's statistics. You might ask me, why do these parameters matter? Why can't we just use statistical data? It's because parameters are important because they allow statisticians to describe real-world populations accurately. Instead of just taking data from a subset of a population, you have to do the process itself where you have to calculate from the parameter data itself. They form the basis of probability models and are the values we aim to estimate using data. It is used in probability distributions like the ones we are used to, especially the bell curve or the empirical curve. It is to help in prediction and decision making using the probability, and then it is to serve as targets for the statistical estimations. There are common population parameters, or the values or the variables we can find within solving population parameters. Different parameters describe different characteristics of a population. Each one focuses on a specific aspect such as average, spread, or proportion. As we may know, statistical data also has the population mean. The statistical data also has a sample mean, a sample variance, and a sample standard deviation. Now, within the common population parameters, we also have the mu, which is also the population mean, the sigma, the population standard deviation, and also the sigma squared, which is also known as population variance. And of course, let's not forget the population proportion, or we can also call it as the n variable within the problems that are given. The population mean is the average within all the data that is given, and the population standard deviation is it identifies how spread out the data is. Now let's move on. So you might wonder, what exactly is a statistic? Well, statistics use different symbols to distinguish them from parameters. These symbols often indicate that the value comes from a sample and is only an estimate itself. Like for example, unlike the previous slide, which we'll go back, which is just a mu, a sigma, a population variance, and a population proportions, all things we are used to seeing, we have these weird numbers here or variables here. You might see an x, which is also called an x bar, which is just an equivalent of the mu, which is, in statistics, it is called the sample mean. We have the s, or maybe the sigma, which is the sample standard deviation, and the p hat, which is the sample proportion. As you may see, there are similarities between the two. These are not very far off from each other, but the only thing that is different is because of its looks. The data and the process of how you handle those data is still exactly the same. It just looks different, and the process of getting the sample size or the population size is still the same. So, a statistic is a numerical value that describes a sample, not the entire population, like I said earlier. Unlike parameters, statistics can change depending on which sample is selected. Now, for example, there are 1,000 people out there. Now, this is the graph that I make, right? So, at the center of this is like 500. So, let's say you select on the right side. That is an example of a sample. Now, in statistics, the data can also form a leptocartic or a leptocartic graph. But on the other side, if you choose the left side, relative to me, not the camera, the left side of the actual population within the parameters, the data may or may not change. Though it is not entirely accurate as to one-to-one ratio of presentation of data, using statistics and solving estimations within your surveys or research can still be a valuable way to gather data and analyze it as per an estimation. Now, parameters versus statistics, which is we will give a comparison. Although they describe similar ideas, parameters and statistics are not the same. The key difference lies in who they describe and what symbols they use. Like I said earlier, though the principle remains the same, there are key differences that makes these two entirely different. We have parameters and statistics, parameters which includes a population, and it is fixed and it uses Greek symbols. Whereas in statistics, it describes the sample, it has a variable, and it uses Roman symbols. Once again, parameters, Greek symbols, statistics, Roman symbols. Now, a parameter is a numerical value describing the entire population. Meanwhile, a statistics is describing a sample from the population. Greek letters, Roman letters. It has the mean, it has the standard deviation, the variance, the proportion, and the proportion. It has a sample mean, it has a sample variance, a sample standard deviation, and a sample proportion. Fixed is the parameter, and when it's not fixed, you can describe it as a statistics. It shows the true characteristics of a population, but within statistics, it can only estimate the population parameter. It doesn't show its true characteristics because you're only taking away a sample from the true population itself. For example, we have over here. In a school with 2,000 students, the true average score, which is the mean or the mu, of all students on a math test is 78. This value comes from every student in the population, representing the actual overall performance. So, what do you think it is? Is it a parameter or is it a statistics? Well, it's a parameter, since it describes the entire population from the word true average score. From the sentence itself, you can basically get that it takes data from the entire population, not taking data from a sample itself. Now let's move on to the next example. We have another one here. If we randomly select 50 students from the same school and calculate the sample mean as 80, this value only describes the selected students, not the whole population. It can vary depending on which students are chosen. So, there's a lot of keywords there, right? You can probably guess what's the real answer. It's statistics. Because it comes from a sample, it is not a parameter. From the keywords too, sample mean. It's literally right there. Sample mean, and it describes the selected students, not the whole population. Let's move on to the next example. In a factory, the probability that a produced bulb is defective is P is equals to 0.02. This value applies to the entire production, representing the true probability of a defect. From the keyword true, what do you think it is? 1, 2, 3. It's a parameter, since it describes the whole population. Let's move on to the last example. If we calculate the standard deviation of 40 randomly selected students as 7.5 centimeters, which is the sample standard deviation, it only applies to the sample, not the population. It can differ depending on which students are picked. From the example, once again, you can say that it is from a statistics, because therefore it is not a parameter, because also it describes 40 randomly selected students, randomly selected. From that wording itself, you can probably guess that it is not the whole population, because you can still select 40 randomly. You can still select 40 students randomly, and it only applies to the sample. So, therefore, that ends our lesson. This lesson is only about describing parameters and statistics, whereas the next lesson will describe how to solve parameters and also how to solve statistics, I think. So, thank you for understanding this lesson, this very short and brief lesson. The end. Thank you, Sir JM, for giving this performance task. Thank you, everybody, for listening to my lesson. I hope you understood, and I hope that you learned a lot from this video. Thank you.